Thank you for joining me today. My name is Tom Monty. I am a senior security analyst at Vectra on the MXDR team. I would like to demo our new EDR module for you. And starting off, we're on the Vectra platform. We see some prioritized hosts, and so let's start here at the top. And starting at the top, we see the host name, tmonty154. We see the urgency score of 100. The priority status is prioritized. Below that, some basic host information, such as the IP that it was last seen with, the last time it was seen online, and also the EDR that it's currently using. Below that, some extra information, such as the attack profile that's related to all the detections that you see off to the right. Below that, scoring factors, and some notes. These notes down here will come in handy shortly, but let's start off with doing an investigation with some of the current detections that we see. Let me zoom in a little bit. Starting off with brute force, there's two IPs that are showing as an internal target, .32 and .99. Both of those hosts are of interest. The .32, however, is a DC. So I want to write that down. Off to the right, we see the type of brute force that's happening. So it's happening over 3389 with RDP and 100 attempts. So making a mental note of the DC and also the RDP type that's brute forcing across this. Moving on to the next, let's look at some SMB account scanning. We can find another IP that's related to that, which we see right here, the 100.32. So we see 8 accounts that are currently being used for this SMB account scan. So we got the DC. We have a few other accounts that are tied to it. So we could start somewhat painting a story of what's going on here. Let's move on to another detection. We have some file share enumeration. So scrolling down, we could see .32 once again. And there's some follow-up accounts that were previously used and some new accounts there. So we have multiple detections all targeting this DC. And let's move on to the last detection, which is a data smuggler. So once again, we see .32 lined up. We see some data being gathered over port TCP 389. And then off to the left, we see an external destination of 10.254.20.154. So right now, the big picture is we have our host, which is being used by this external host, and it is talking to this DC. We can make those assumptions right now. So the cool thing with this is we could actually go back to our main page and click on our EDR detections. Let's view those. We have some information here that's being passed over. With that said, we'll pop over to the EDR side to get a better idea of what's going on. All right, now that we're in that CrowdStrike environment, we can dig into that host with the detections, tmonty154. Let's look at that first detection that came up. So off to the right, it was a PowerShell command. Looking at the command line, it shows that it was reaching out and downloaded a file. So we could dig into the actual detection itself. Let's go back a step to the parent process of that PowerShell. And we could see that it was a C users, tmonty154, in the downloads, in their downloads folder, a file called http_launcher.bat that originated this. So going up, we see that there's a few detections relying about this. There's 34 detections in this single one. So let's actually pull up the full detection details for that specific detection. So pulling up that detection, we see the PowerShell detection that we just previously looked at. And after that came something that https_backdoor.exe, an executable that ran on the system that looks like it did some nasty stuff. So scrolling all the way down, we could see all the different processes that started. Going all the way from the beginning, we see a 7-zip file that loaded up a command line of tools.tar, followed by a bunch of other commands. And digging into each of these commands appears to be some recon activity It's trying to get some host discovery, see what's going on with it, different things such as the different patches that are installed. It's looking to see what antivirus is installed. And then after that comes Mimikatz, which is known to dump passwords, which comes up with CrackMap exec, and a ton of other CrackMap exec detections. And in between that, we see Hydra. And looking at the detections here, the command line, it shows that it was using RDP users.txt. Now, when we go back to the actual Vectra side, we see that brute force over RDP. That was Hydra doing that. So there's some crossover there. So having the Vectra side and having the EDR side with CrowdStrike, we're kind of able to paint that picture to see what's going on. When you just have one or the other, you don't really have a great idea of what is going on. So digging into the other processes, we can see that CrackMap exec, the command line here was looking for users and trying different users on the network here. Each one of these is a different host that it's trying to use a various user on, which comes back once again with some of the other detections that we have seen. With the known DC and Vectra, we are given the full scope of the incident. Let's go back to that detection. So a ton of CrackMap exec searching for users. It's searching for logged in users. And let's follow up. Here's a few more. Looking for shares. Once again, that brings up the SMB side with what we've already seen in Vectra. And then Sharphound gets dropped as a suspicious file, which once again, it's able to search the network with various names that it knows, trying to push out the different shares over SMB, and it's still trying to find different administrator accounts and dig further and further into this host. So we can confirm that this host itself is compromised, and most likely a lot of the other credentials are compromised as well. So let's bring that back, right? So we have an incident, we have a general idea of what happened, the tools that were used locally, and those tools that were used locally, we also see on the network on the Vectra side. So as altogether, what is the Vectra MXDR platform service really doing for you? So it comes back to this. At the top, you can see that the same attack took place, but the executions were blocked. And we can tell this by the green check mark, by the detection based on the prevention policy that these hosts are aligned with. Vectra MXDR has a standardized policies which align with either a vigilant, balanced, or dynamic. These prevention policies are configured and managed by the Vectra MXDR team. So based upon which prevention policy you align your organization with, it really dictates the level of prevention of malicious software that's detected or detected and blocked, how much action's being taken. So for this detection specifically, you can see that we have it's a balanced prevention policy. And to bring up the other two, such as like the dynamic policy, if you have hosts on your network that are issued out to contractors, or it's you have a library, you have public machines out there, and you would put those hosts on a more dynamic policy. So as soon as it suspects something, it will instantly contain that host and lock down the user that's there, and it will not be able to move anywhere on the network depending on what they're doing. A vigilant policy is for those mission critical hosts, which as soon as you install the sensor on that host, you want to test to make sure that just running the basic application, say on a SQL server, that the sensor isn't blocking known good code. So you start off in a more vigilant policy and then hopefully move that down to a more balanced when your actual environment is set up and configured properly. There is some tuning that is always involved with EDR, and that's why these prevention policies are in place. We standardize them, we tune it to your environment, and we truly try to make it seamless. So moving forward, so let's look at this detection here. such as the PowerShell. It shows that the malicious PowerShell script was blocked. We could actually dig in and pull up this file. And what we would do on the Vectra MXDR side, depending on either way, right? If you have the Vectra MXDR, your policies are in place. If something comes up, we come in, we remediate the bad things that happen. As this is a malicious script, we would go in and we would remove this script from the network, or from the host, excuse me. And I'll show you a summary of what gets written up from our side. All right, so now our batch file is now gone. And what this really does, what this shows with having our prevention policies, having us manage your hosts, we would, if it was not managed, this is everything that original script ran and what we had to remove. There's multiple pieces to this. It downloaded multiple tools. It wrote stuff to temporary files and created the password list. It also had a scheduled task that we needed to remove. And then our recommendations from the Vectra MXDR side would be to review all the hosts that were touched and pretty much do a complete reset of credentials and to dig into that host 10.254.20.154. However, with those prevention policies in place, with us properly managing it, it comes down to having that single file removed, as that script was not able to be ran. And so we would still see that the host 10.254.20.154 is on the network and would need to be dug into, as it appeared to be an unmanaged host since there wasn't a sensor installed on it from the EDR side. So we aren't able to get information from it from there. But that would be our recommendation straight up from there, instead of having that complete load that was dropped on that host, everything that was reaching out, Mimikatz doing its thing, Hydra doing its thing, all those users being popped. It's now become a smaller incident. It's still an incident, which we would call on both sides. We would still call you. We would most likely, depending on its prevention policy, contain the host. As I mentioned before, that vigilant prevention policy, we have to get your confirmation to contain the host. So if it's a mission critical host and you're going through a pen test, you may not want that web server to go down. So we'd have to give you a call, confirm it with you first. However, if it was on a more balanced prevention policy, we would contain that host, give you a call while we are containing it, and start gathering more information from your side, share that information out, and proceed with that incident. So let's go back to the Vectra side. All right, now that we are back at the Vectra UI, we just want to let you know that we can help integrate and cater to your needs. Be sure to speak with your security specialist with the Vectra MXDR team to see what will work best in your environment. And thank you for your time today.